Good morning, everyone. My name is Kathleen S. Iumagi, a third-year student taking up Bachelor of Science in Information Technology at Negros Oriental State University. So for today's video, I am going to discuss the networks, subnets, and CIDR. So there are networks known as classful and classless. The first plan adopted and used widely by the Internet community were classful networks, so named because three address classes A, B, and C were defined with assignable IP address space. These classes, however, disproportionately distributed the number of available IP addresses. A new method to identify networks and allocate IP addresses was needed to support the continued growth of the Internet. The new method is named classless because it does away with the idea of classes altogether. It is commonly known as classless Internet Domain Routing or CIDR. It is much more flexible than classful networks, and it is what the Internet uses today. Classful networks are still used by many devices, so it is important to understand both classful and classless networking. So IP version 4 overview. An IP version 4 address contains 32 bits. It is usually represented in that decimal quad notation, so it is easier to read and communicate. Computers, of course, read this information in binary form. And in order to calculate subnet mask, network addresses, and broadcast addresses, the binary value must be known. Converting a decimal IP address to binary is simple, given that there are 4 numbers. Each decimal number is represented in binary as an octet. The high-order bits in binary are always the leftmost ones. The following is how IP address 68.125.16.250 will be converted and represented in binary form. So here, this is the example. So in decimal, we have 68, 125, 16, and 250. And it's broken down, it's 64 plus 4. And then for 125, it's 64 plus 32 plus 16 plus 8 plus 4 and plus 1. For 16 is 16 rajud siya. So for 250, we have broken down, it's 128 plus 64 plus 32 plus 16 plus 8 and plus 2. So if we are going to in the binary edition, ang 68 hima na siya 2 plus 2 to the power of 2. So pag naabot na siya sa binary form, we have 0100 So for 125, sa iyang binary addition, we have 2 plus 2 plus 2 to the power of 4 and plus 2 to the power of 3 plus 2 to the power of 2 and plus 2 to the power of 0. So pag binary na niya, we have 0, 1, 1, 1, and 1, and 0, 1. So sa ato ang 16, sa iyang binary addition, we have 2 to the power of 4. So sa iyang binary, we have 0, 0, 1, 0, 0, 0, 0. So sa ato ang decimal na 250, sa iyang binary addition, we have 27 plus, it's 2 to the power of 7 and plus 2 to the power of 6 and plus 2 to the power of 5 and plus 2 to the power of 4 and plus 2 to the power of 3 and plus 2 to the power of 1. So pag binary na siya, we have 1, 1, 1, 1, 0, plus 1 and 0. So this is the result. Look alike. So here, as you can see. So let's proceed. We have classful networks. Once an IP address is represented in binary format, The class of networks can be determined rather easily, beginning from the left of the IP address. The first bit that is not A1 indicates whether it is a class A, class B, class C, or class D, or class E network. So for class A network, the high order leftmost bit is always 0. For class B networks, the high order bits are always 1, followed by A for 0. For class C networks, the high order bits are always 1, followed by 1, followed by 0. So we have here first bit, class A, class B, class C, class D, and class E. So for CIDR available hosts, the formula to calculate the number of assignable IP address to CIDR network is similar to classful networking. Subtract the number of networking bits from 32, then raise to the power and subtract 2 for the network and broadcast addresses. For example, A for 24 network has 232 minus 24 minus 2 addresses available for host name. So what we have here an example of CIDR notation, and we also have host formula and then the available host. And let's proceed. As the table indicates, 29 networks equal A to 28 networks, 2 to 28 networks equals A to 27 networks, 2 to 27 networks equals A to 26 networks, and so on. So the notion of combining two smaller networks into a larger one is another benefit of classless network named supernetting. In order to create a supernet, the smaller networks must be contiguous. So we have here, for example, it's 192.0, then dot 2, then dot 240 over 29, and so on. So CIDR subnet mask. The process to determine the subnet mask for a CIDR address is straightforward. The number of bits in the network portion of the address are converted to 1 and right padded with 0 until there are 32 numbers. So the sequence of numbers is then divided into 4 octets. From then, it is a matter of converting the 4 octets from binary to decimal. So we also hear an example. So here we have CIDR notation, and then the convert to 1 and right pad, and then the subnet mask. So here is guys. So let's proceed for subnet. So what is subnet? A subnet is a logical subdivision of an IP network. The process of dividing a network into 2 or more networks is called subnetting. The main purpose of subnetting is to help relieve network congestion. So we have here the IP address classes. So for class A, we have 1 for 127, 1 for 127. Its network is reserved for loopback and internal testing, and then the leading bit pattern is 0. And for class B, we have 128 to 191. So its leading bit pattern is 10. So for class C, we have 192 to 223. Its leading bit pattern is 110. So for class D, we have 224 to 239, and it's received for multicast. So for class E, we have 240 to 255. So it's reserved for experimental use for research. So we have the private address space. So it is look like it's class A for 10.0002 to 10.255.255.255. And then for class B, we have 172.16.0.0 to 172.31.255.255. So for class C, we have 192.168.0.0 to 192.268 to 255. So its default subnet mask for class A is 255.0.0.0. So for class B, ang default subnet mask is 255.255.0.0. Class C 255.255.255.0. So let's proceed to binary to decimal conversion. So as we can see, guys, based of my understanding for this topic on how to get binary to decimal conversion is, in order to get 146, so for example kaning sa first, so we have the given numbers 128, 64, 32, 16, 8, 4 plus 2 and 1. So para makuha nato ning 146, we just need to add the 128 plus 16 plus 2. So ang kuha ana is 146. And then diri sad sa second, for example sa 119, to get 119 we just need to add the 64, the 32, the 16, the 4, the 2 and 1. So like if mo add kag numbers, if you're going to add the numbers na imong total numbers nga gipangita, if ever for example kaning 128, if ato siyang i-add sa 64, mula pa man siya sa 146, so dili siya pwede. So we just put it automatically a 0. So in ano siya, guys, for example kaning sa 1, so atong i-add ang 128 to 16, dili man siya mula pa sa 146, so ato na siyang butangan og 1. So let's proceed to decimal to binary conversion. So we have here the example in number 1. So we have given numbers 128, 64, 32, 16, 8, 4, 2 and 1. So equals 255. So second, it's 238. In order to get 238, we just need to add the 128. 128 plus 64 plus 32 plus 8 plus 4 plus 2. So if you are going to add that, ang magawas ana is 238. Then next, address class identification. So ang ato ang class A is, ang iyang address is 10.250.1.1. Then let's proceed to network and host identification. So we have, as you can see, guys, gi-encircle na ang, which is there is a 177.100, it is the network portion. Then sa iyang host identification, we have, gi-encircle lang Japon siya, it's 15.123.50. Then sa second, ang iyang network portion, we have 119. Ang iyang host identification is 199.31. And then let's proceed to network addresses. So using the IP address and subnet mask shown write out the network address. So we have here example, it's 188.10.18.2. So iyang network addresses, it's 188.10.0.0. Then so on and so forth. So let's proceed to host addresses. So using the IP address and subnet mask shown, write out the host address. So here, I think the example is just the same. So ang iyang host address sa 188.10.18.2 is 0.0.18.2. So the second is 10.48.80. So ang iyang host addresses is 0.0.0.80. The next we have default subnet mask. So write the correct default subnet mask for each of the following addresses. So we have here the first, ang iyang ang default subnet mask sa 177.100.18.4 is 255.255.0.0. And then sa 119 we have 119.18.45.0. Ang iyang default subnet mask, we have 255.0.0 and .0. So let's proceed to ending with default subnet mask. So every IP address must be accompanied by a subnet mask. By now, you should be able to look at an IP address and tell what class it is. So unfortunately, your computer doesn't think that way. For your computer to determine the network and subnet portion of an IP address, it must end the IP address with a subnet mask. So default subnet mask, we have here the class A, class B, and class C. For class A, it's 255.0.0.0. For class B, it's 255.255.0.0. So for class C, we have 255.255.255.0. So sa ending equation, we have 1 and 1 equals 1. And then second is 1 and 0 equals 0. So sa third is 0 and 1 equals 0. So last is 0 and 0 equals 0. So sample, we have example of IP address. So like for example, it's 192.100.10.33. Ang iyang address class is C. Ang iyang network version is 192.100.10.33. Ang iyang host portion is 192.100.10.33. In order for your computer to get the same information, it must end the IP address with a subnet mask in binary. So, for example guys. So, iyang IP address. Then we have the host. Then ayan na po siya default mask. Then we have the end. So ending with the default subnet mask allows your computer to configure out the network portion of the address. So that's all for today guys. Thank you.